Hey, Jonathan here at Colfax Math. I'm just going to go over some of these problems where it's a double angle. So cosine of 2x equals the ratio of sides. 2 cosine of 3x minus 1 equals 0. And we're solving within a given domain of negative 180 to 180. So let me do that first one here. So this is the section before we introduce double angle identities. Section 12E in the IB Math SL book. So cosine of 2x, the way I isolate 2x is I take the inverse cosine of both sides. That inverse cosine will cancel with that cosine, and then I have 2x is equal to the inverse cosine of root 3 over 2 within this given domain. So this is a triangle where the SOHCAHTOA TOA adjacent over the hypotenuse, where the adjacent is root 3, the hypotenuse is 2, and that would be a 30, 60, 90 triangle. Or you could use the Pythagorean theorem and say root 3 squared plus 1 squared equals 2 squared. And that's also going to happen down here where the adjacent is root 3 and the hypotenuse is 2. So those would be my triangles. The angle opposite them would be 30 degrees and negative 30 degrees. So those are my two angles with that ratio of root 3 over 2. So then 2x is going to equal 30 degrees plus 360n, or 2x could also equal 330 degrees plus 360n. So that's the general solution for 2x. And if the domain is x between negative 180 and 180, then it would also be the same as 2x between negative 360 and 360. So I want all values for 2x between negative 360 and 360, and I have these general solutions. So 2x could equal 30 degrees, 2x could equal 330 degrees, 2x could also equal negative 30 degrees or negative 330 degrees. So then dividing both sides of the equation by 2, x could equal 15, negative 15, 2x equals 330, 150, 165, or positive 165 degrees. So I solve for an infinite series of solutions for the inverse cosine of root 3 over 2, and that's what 2x is equal to. Okay, so those are the four solutions within this given domain. And let's take a look at another one here. Let's take a look at B. B is going to be pretty similar. Cosine of 3x is equal to root 3 over 2. That's going to be the same set of triangles where my adjacent is root 3, my hypotenuse is 2, and that'll happen both at 30 and negative 30. So that'll happen at those two angles. Remember that x is greater than or equal to negative 180 or less than or equal to 180. So 3x, I'm going to multiply this by 3, so I have to multiply all sides by 3. So 3x is greater than or equal to negative 180 times 3, or 180 times 3. So again, my general solution here is 30 plus 360n, and then 330 plus 360n. And in this general solution, I'm looking in this domain. So 30 would work. 330 would, remember this is 3x. 30 would work. 330 would work. I could go 360 plus 30, 390 would fit in there. But this one of 360 plus that 330 would be outside that domain, so that will not work. go in this direction between 0 and negative 540, I would have negative 30 would work, negative 330 would work, and then also negative 390 would work. So 3x could equal any one of these 6 values in this given domain. So I'm going to divide both sides of the equation by 3 to get x could equal 30 divided by 3, 330 divided by 3, 390 divided by 3, negative 30 divided by 3, negative 330 divided by 3, and negative 130. So I have all these solutions in this problem when it's cosine of 3x equals root 3 over 2 versus these solutions if, these solutions right here when it's 2x equals root 3 over 2. Same ratio, same triangles right here, but the 2x is going to give me 2 less values than the 3x is going to give me. Let me do one more. Let me do part D here. So this is section 12E, number D. It says 3 tangent of x over 2 plus 3 is equal to 0. Again, this is the same domain. First thing I'll do is I'll subtract 3 from both sides. So tan of x over 2 is equal to negative 3. So I'll subtract that 3. Then I divide both sides by 3 to get rid of this. So then I have tan of x over 2 is equal to negative 1, or negative 1 over 1. That's saying the opposite is negative 1. The adjacent is 1, so a 45-degree angle. Or down here, the opposite could be negative 1 and the adjacent of 1 with a 45-degree angle. So within my domain, negative 180 to 180, I take the arctan of both sides. That'll give me x over 2 by itself. Arctan of negative 1 over 1 will give me the 135 degrees. Or going this way, negative 45 degrees. Solving for x, I multiply both sides by 2, and I get x by itself is equal to 270 degrees. Multiply both sides by 2, and x is equal to negative 90 degrees. Okay, let me do number 2 here. So in number 2, the domain's different. It's 0. Theta is between 0 and 2 pi. And then they give you sine of 3 theta is equal to root 3 over 2. That's an opposite over hypotenuse. So the opposite would be root 3 over 2. Or it could happen here in the second quadrant where the opposite's root 3 over 2. Pythagorean theorem, 1 squared plus root 3 squared equals 2. I recognize it as a 30, 60, 90 triangle. So I could see I have a solution here at 60 and at 120. Or if I'm in radians, pi over 3, 2 pi over 3. So that's the inverse sine of this problem. So 3 theta is equal to the inverse sine of root 3 over 2. 3 theta is going to equal, well, if theta is between 0 and 2 pi, 3 theta is going to be between 0 and 6 pi. So my solutions within this window for 3 theta between 0 and 6 pi would be pi over 3, 1/3, 2/3, and then 2 pi plus 1/3. So that would be 7 pi over 3, 2 pi plus 2/3, 8 pi over 3. And then finally I could go into 3 revolutions. So it'll be 4 pi, 4 pi plus pi over 3 4 pi, I gotta write that out, 4 pi plus pi over 3. So I'm going to common denominator 3, that would be 12 pi, 13 pi over 3, and 14 pi over 3. So there's 1, 2, 3, 4, 5, 6 solutions in this domain of 3 theta. So 3 theta could equal all 6 of these values here. And then theta, if I divide both sides by 3 to get theta by itself, I'm going to divide this by 3 to divide this by 3, which is multiplying by the reciprocal. It'll give me pi over 9, 2 pi over 9, 7 pi over 9, 8 pi over 9, 13 pi over 9, 14 pi over 9, and those would be my 6 solutions for sine of 3 theta equals root 3 over 2 within this domain. They're tricky. They're pretty hard. Okay, well, thanks for watching. Hopefully that helped. I'll let you figure out the rest of them from there.